we're going to be solving equations now that have that stuff in it that we were dealing with yesterday, those fractions with exponents. So we're going to do the same thing, but they're going to be equations where we have to solve for x. Okay. So, without any further ado, we shall begin. Oh, you want need to switch this a little bit. We'll call this example 1, and this will be part A. So go ahead and write that down there. Okay. So here's kind of like the main strategy for today. The new idea that we're going to be using, we'll be using it on every problem. To cancel a fraction power we're going to raise both sides of the equation to the reciprocal power. So that's our main strategy for the day. So I'll wait a second for you to write, and then I'll show you what that looks like. But our main strategy for today is we're going to need to cancel out that fraction power. The way we're going to do that is by raising both sides to the reciprocal powers. So you don't need to write this. I'm just going to review something with you before we get started. We talked yesterday about how, like, if you have x squared and you raise it to the 5th power, you multiply those together to get 10. We also talked about what we're going to do today, which is I'm going to use that back to cancel this power out, right? So we have x to the 1/4 equals 2. Well, I want to cancel out that 1/4. The way I'm going to do that is I'm going to raise this side to a power that's the reciprocal of this fraction. In other words, the flip over of it. So instead of 4/1, I'm going to raise it, instead of 1/4, I'm going to raise it to the 4/1 power. Okay? Which, now why would I do that? Because when you multiply 1/4 times 4/1, you get 4/4, which is just 1, right? So basically these things cancel each other out, and it leaves you with x. So remember, I'm trying to solve for x. I want to get x by itself. So I got rid of the fraction power by raising both sides to the reciprocal power. But I haven't done the other side yet, right? Anytime you do something to one side of an equation, you have to do it to the other. So I'm going to raise this side to the 4/1 power. Now, 4/1, what can I write instead of 4/1? I can just put 4, right? We don't need the 1 on the bottom. And so the answer is 2 to the 4th power. What's that? 16. Now, if you don't know how I got the 16, maybe you can make a little note here. 2 to the 4th power means 2 times 2 times 2 times 2. So you're multiplying 2 by itself 4 times. That's that. So that's the main strategy we're going to be using today, is raising both sides to the reciprocal power, but there'll be some other little things coming up along the way. But that's the main skill I want you guys to have there. Okay. Can I delete? All right. I'm going to wait on that one. I'm going to... I guess I'll do that one. All right, let's go ahead and do this one. This will be example, it's still example 1, but we're going to make this part B. So go ahead and write down that one there. Okay. So let me ask Amaya, what power am I going to raise both sides to cancel out the fraction there? So let's start by putting some parentheses here, and I'm going to put the reciprocal power there, and I'm going to put it on the other side also. Okay, now these powers over here. Well, let me ask somebody. Brianna, what happens with these powers here? What's that? Not sure. Neana, what happens with these powers here? They cancel each other out. So boom and boom. They really make one, but you don't have to write it, so we'll just say they cancel each other out. Okay, so far that's just like example 1 that we did together, 1A, but now things are going to get a little bit different. So the first thing that we're going to do to simplify this now is we're going to change this into radical form. So take a minute and see if you guys can figure out what goes in these 3 blanks here. I'll give you a second to figure that out, and then I'll ask you what you got. Check your answer with a buddy. That's what we did yesterday, right? Okay. So Edwin, what do I write here? What's the root?
2, and you can write that.
That's right. 25. And 3. Okay. So now this one's not too bad. We could probably, I guess I'll show my work, but you could do this one mentally. Does anybody know what the answer to this is? It's just 5. So if you know it, don't show your work, just write the answer. That's fine. But for other people that might need to see the steps, because there will be ones where you need to see them. Let's go ahead and do that on the side here. 20. Let's do this part first, right? This is like what we learned yesterday at this point. So 25 breaks apart into 5 times 5, right? And we're looking for groups of how many? 2. I have that, so I'll cross out that group and put that number on the outside, and the answer is just 5. That's all there is to it. But like I said, if you can see that, it's just the square root of 25, and you know what that is, go ahead and put it. Now, I'm going to do something that is a little bit irritating. But make sure you write this note down. Circle that. Draw a line here in the arrow. And let's say when solving for x, if the root is even, you get plus and minus. And then draw an arrow to there. Okay? This only applies if the root is even. I'll explain why in a minute, but I want to finish the problem first. But I definitely want you guys to remember this. Whenever you are taking an even root of a number with these types of problems, you're going to get two answers, a positive and a negative. If it's an odd root, you don't. So if this were just like a 3 or something, then I would only have one answer. Okay? But if it's an even root, we're going to get a positive and a negative. Let's go ahead and do the next step. What is 5 to the third power? Good. And how about negative 5? What's negative 5 to the third power? That one's negative 125, right? So you get two answers on this one. So I ran out of space, so I'll put it up here. So I'll put x equals 125 and negative 125. Okay? Why did I write two things? Because once again, we get a plus and a minus, right? Now, some of you guys may wonder, why does that happen? Why does that happen? Well, originally this 2, which is a root, was on the top over here, right? Think of it this way. X squared equals 25. What number to the second power equals 25? 5. But also negative 5. Because negative 5 times negative 5 also makes 25. So anytime you have an even power here, the even cancels out the negative, and so technically the negative counts also as a possible answer. So over here it's a root, but it used to be a power over here on this side before I solved for x, and so that's why you get a positive and negative. But that doesn't happen with odd powers. So if you have like a 3 or a 7 or something, it's always just going to be whatever sign it was, it stays that way. All right, so let's review. Step 1, reciprocal power. Step 2, change it to a root. Step 3, do the root. Step 4, do the power. If you have an even root, don't forget to make it a plus and minus. So let's toss a couple of these your way and see how you guys do with them. Okay? Yeah, this is student practice. All right, so Adrian, what's the first step? All right, so there's the main strategy we're going to be using today. I'm going to move on to some other types of problems now where there's other numbers in the way that we have to move out of the way, but other than that, this is the main idea. Yeah, so you could write it like this, or you can write it like this. It might help to write it like this because on the problems that are going to come up, we will need to have them separate to finish solving it. So let's go ahead and take a look at our next one. All right, so this is example 2. So go ahead and write down example 2, please. Okay. So here's a note that we'll write down for this problem. what's different about it is we want to get rid of numbers that aren't affected by the power first. So the first thing that we want to do is get rid of any numbers that are not affected by the power. So in this case, what has the power on it here? The n does, right? Just the n. Only the n is being affected by the power. So what's not being affected by the power? It's the -2. So I want to get rid of that -2 first. So any numbers that are not affected by the power, we're going to get rid of those first. So in this case, I'm going to get rid of the -2. And how do I get rid of the -2? Divide it. Now some of you guys might have been thinking add because it's negative, but it's -2 times n, so the opposite is division. So we're going to divide both sides by a -2. -18 divided by -2 is 9. After that, look at that problem. That looks like just what we did, right? So basically, get rid of the numbers that aren't affected by the power. After that, it should be just like the other ones that we did. Cal, you're missing a lot, bud. You should be with us. All right, so we're going to raise both sides. Now this next part, I'm just going to buzz through the rest of this kind of quick because there's nothing new happening here. But we're going to raise both sides to the reciprocal power. On the left side, the powers cancel out, so I'm just left with n. And on the right side, I'm going to rewrite that as a root. So this is a square root, right? Because there's just a 2 here. And this is one we could probably just do mentally. What is the square root of 9? It's 3. Question for you, though. Is it 3 or is it plus and minus 3? Plus and minus because we have an even root, right? And then I'm going to cube it. So I get 3 to the third power is 27. So it's plus and minus 27. So I'll wait in case you're still writing. But I'm not too concerned. I went kind of quick through this stuff, but I'm not concerned about that because that's what we just spent all of our time on before. The first step is what was really important here on this one. I wanted to illustrate to you guys the importance of getting rid of numbers that are not affected by the power first. Okay? Am I good to delete? I'm still writing a little bit. I'll wait. And can I count up? 1, 2. Remember, did you guys have swings at your elementary schools in your kids?
Yeah.
Did the kids stand in front of your swings and count?
Yeah, but the rule was they made a rule where you could only count when their feet go up.
Rules are good. Keep things fair. Otherwise, they're like, what do you do? I hated that.
They counted at the waterfall.
It takes all the
Yeah,
Drink the
I
water.
hated that.
I hate it's like it takes all the fun out. You're sitting there swinging, you're free, and there's some little punk sitting in front of you counting. You're like, I'm trying to enjoy
when
this.
you don't get off, they call one of those booty.
Yeah.
But that just gives you an extra 5 minutes. I mean, what are the duty aids going to do? I'm just kidding. That's bad. Get off the swing when it's not your turn.
Oh, they would pull me off the swing if I didn't get off.
When I was a kid, my friend and I liked to do like weird things on the playground equipment. Like I would go as high as I could, and then I would flip off of the swing. I'd do like a flip and try to land on my feet. And on the monkey bars, we tried to like. You guys probably didn't have these, did you? Like the monkey bars?
Yeah.
You did?
Yeah.
Oh.
Well,
See, I don't think those are there anymore because when I go to the public park, they have these really weird play equipment things, and I didn't know they still have these at the schools. But anyway, I was standing on mine. We tried to see if we could jump out furthest and grab the bar the furthest.
Oh, you used to do that too.
Did you?
Yeah.
I was going for the middle bar, which was probably about 10 bars out because we were getting pretty good. And I slipped and I landed like this. And when I got up, my arm looked like a Z shape.
Did you break it?
Yeah. It sucked. It wasn't fun. But hey, what it means to go for the gold. All right. Let's take a look at this one. Now, I'm not gonna have you guys do the whole problem. I just want you to do the first step. The first step is to get rid of the number that's not affected by the power. So go ahead and write this down. We'll call this student practice 2. And all I want you guys to do is the first step. Get rid of the number that's not affected by the power. So you have to find out which number it is, which number is not affected by the power, and you got to think about how to get rid of it. Check your strategy and outcome with a neighbor. Shouldn't take too long. We're just doing the first step. I'll give you the rest of the answer in a minute. Just the first step. Oh, you know what? Subtract. So on this one, subtract. But you have the right idea, just did the wrong operation. All right. So let me ask Shakir, what number do I want to get rid of? Good. Stephen, how do I get rid of the one? On this one, we're subtracting it. We're not dividing it, right? Because this one is being added to n, so the way you get rid of it is subtract it. So just know it's not always division, it's not always subtraction, it could be anything. The goal is to use your Algebra 1 skills to know how to get rid of that unnecessary number there. Okay, now I just for the sake of getting through it, because I feel like it would, you guys are still learning this, so this would take you a little bit of time to figure out on your own. But we've seen that you guys can do it. I'm just going to buzz through it so we can move on to the next problem real quick, okay? So the next step is to raise both sides to the reciprocal power, which leaves me with this. I'll wait for a second if you're writing. The next thing I would do is I would find the fifth root of 243. And I just happen to know that that's 3. Do I need a plus and a minus? No, because it's an odd number this time for my root. And so the answer is just going to be 81 again. So, for example 2, the point was to illustrate get rid of numbers that are not affected by the power. Example 3 is going to have another little twist to it. I see some pencils still moving though, so I'll wait a little bit more. So let's take a look at example 3. Go ahead and write down example 3, please. This will probably be our last set for the day. I will have you do a student practice for this one. This one's a little bit different than the others. A lot of the same stuff in it, but there is a twist with Okay. So on this one, notice that we have these parentheses, right? And inside the parentheses, there's a letter and a number. Now, is the number being affected by the power in this case? Yeah, so you can't get rid of that 10. If I had written the problem like this, 216 equals, if I wrote it like this, then you would get rid of the 10 because it's not being affected by power. You just move it over. But it's not like that this time. This time the 10 is affected by the power, so I can't move the 10 yet. So what I'm going to do is I'm going to start by getting rid of the power like I have on all the other problems. So we're going to put some brackets here, and I'm going to raise it to the reciprocal power. So that's 2/3. So let's start off with that. And so on the right side here, those cancel out, and I'm left with x minus 10. And on the left side, I have 216 to the 2/3 power. So I'm just going to go ahead and change that into a root now. What's my root? 3. And the radicand, the number inside is 216, but yeah.
Oh, yeah.
And the power? 2. All right. Now, in the interest of time, I'm going to skip my work for this step because we've done that a few times. But we would break this number down and take out groups of 3. Okay? And you should end up getting 6 if you did that. So, I'm just going to put a 6 there. But question for you, is it a plus and minus 6 or is it just a 6? Just a 6. All right, and what is 6 squared? And what do you think I do now?
Add the 10.
Now you get rid of the 10. So this one has an extra step at the very end. So these problems that have the parentheses with a number inside, you saw it like we were doing all the other ones today first. And at the end, then you get rid of that number that was on the inside. So I'm going to add 10 on both sides. And I get 46 as my answer. Now, it's possible that let's say I did get a plus and a minus 6 here, right? If I got a plus and a minus 6, you'd have to write 2 separate equations and add 10 for both of them. I might throw one of those at you a little bit later, but not today. Because we're running low on time. But are we good to erase? So let me throw one of these at you and we'll call it a day. And I'll come around and check notes. So let's see what you guys can do with this. Don't forget, guys, you're gonna see the number 6/1 here. But what's an easier way to write 6/1? Just make it 6. Just so you. I didn't show my work, but that's what we've been working on for the past 2 days. So try to get the break this down and day afterwards. Did all that here. So now, if you guys have gotten to this step here, sorry. Some of you guys might have done this. You don't have to do that. It just makes things a little bit harder. Because what I said here is 6 over 1, what is that? That's just 6. So it's easier just to do that. Okay, but this works. I'm looking for groups of how many? 1. So the answer is just 2, right? It's still 2 to 6. It's just that that's why I say for this one, don't bother with that. So that would be. So I believe you should be getting 74.
Yeah.
All right. I'll finish checking on notes and then call it a day there. There were a couple more things, like another few examples I want to go, but we'll do it tomorrow. We have time, because tomorrow was going to be a study guide day anyway. Add 10 at the end. All right, thank you guys. All right, we'll call it a day there. I'll show the work for this in case you wanted to see it.